Welcome everyone. I'm Tracy Fitzpatrick and I'll be your moderator today. Thank you so much for joining us here at Netcom Learning, a market leader in promoting lifelong learning, training, and talent development solutions. We are very excited to host today's event, Building Next Generation IT Networks, Best Practices and Implementation Strategies with Cisco ENCOR v1.2. Presenting today's topic is Talib. As a certified Cisco systems instructor and a Netcom Learning subject matter expert, Talib is an IT veteran with over 24 years of specializing in the data center, security, and service provider network infrastructure. With his domain expertise in network consultancy, training, pre-sales, project management, virtualization, client server support, system architect design, system administration, network design setup, and problem identification resolution, he has trained diverse corporate clients and individual students. Now, please bear in mind that this is an overview of a very robust topic. We offer a collection of technical and business courses that can be tailored to your specific requirements. If you are interested in a further discussion, you can make an appointment with our learning consultants through our website at netcomlearning.com. Today's session is also being recorded, so you'll get free access to the recording in the next 24 hours via email. Netcom Learning helps customers build innovative learning organizations by achieving a smarter workforce, adapting to change, and driving growth. We do this with a broad catalog of offerings, developing customized learning plans, and our global delivery capabilities. Since 1998, we have been empowering organizations with our managed learning services to help them reach optimal performance results and address challenges. We do have 9 practice areas in which we specialize. They encompass people, process, and technology training. Today's presentation is from the networking practice area. Netcom Learning offers a comprehensive training portfolio of courses for the topic being covered today. Our upcoming classes include various trainings on the given courses. You can also access a variety of marketing assets, such as the free training and blogs, by clicking on the available event handout. These offerings can be found with a simple search on our website at netcomlearning.com. Today's session will equip you with valuable insights and practical tips to excel in network design and troubleshooting. Our trainer will guide you through the intricacies of implementing security principles within an enterprise network and overlaying network design using cutting-edge solutions like SD Access and SD-WAN. And now I would like to give you a quick overview of the logistics before we get started. To begin with, you do have the option to view in full screen by clicking on the full screen button on the right side of the GoToWebinar viewer. Simply hit the escape key to exit the full screen. Everyone has been muted except for our presenters. Feel free to submit any questions you have for the presenters here in the questions pane, and we will address them at the end of the session. And to get the best out of today's events, we've included the slides, courses we talk about, and marketing assets in the handouts section of your GoToWebinar viewer. You may refer to them at any time to get a better understanding of today's topic. And we do realize that some of you may have to leave early and want to let you know that as you do leave the session today, you will be presented with a short survey. We would like to request for you to take a quick moment to participate in that survey. Your feedback really helps us understand your learning experience and improve our future sessions for you. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. And now I'd like to pass this over to our trainer to present today's topic. Hey Talib, thank you so much for joining us today.
Okay, guys, now we are starting our webinar, Building Next Generation IT Network Best Practices and Implementation Strategy with Cisco ENCOR. version 1.2. Let me introduce first myself. My name is Talib Bakhtiari. I've been in industry for last 24 years, mainly working with data centers, route and switch networks. Uh, Also have very good experience with Cisco security product, service provider based network, and especially today we have very exciting webinar. Okay, in this training, we really wanna give you a base idea what we're gonna learn later when you guys want to join this training, what kind of things we really want to discuss in that training. So let me tell you about ENCOR. ENCOR basically, it's a part of CCNP core exam. In order to pass CCNP, you need ENCOR first, and after that, you can choose any other optional exam. Okay. So once you pass ENCOR, you will qualify for CCNP after one optional exam, and then you can also qualify for CCIE labs. Okay, so which is 8 hours lab after ENCOR. You will qualify for CCI labs. There is no need for a separate CCI written exam. Cisco started this policy for last four years. Okay, so lots of advantages of this training. Plus, once you go for this course, you will get credit hours, and those credit hours are really good for you if you really want to recertify, you want to renew your certifications. So you're gonna get 40 credit hours. Let's say you have old CCNP and that gonna be expired, so you can renew your CCNP or CCNA with the help of this training or with the help of attending this course. Okay, so let's start. Uh, what is our agenda today? We're gonna discuss network design and troubleshooting. Basic introduction. Okay, I'm gonna give you 10,000 foot overview of network design and troubleshooting. Okay, and after that, we're gonna discuss network design models and switching mechanism. Especially our focus will be hierarchical network design model and different switching mechanism, especially we are using in Cisco devices, switches and routers. We're gonna talk about that. And then we're gonna discuss layer 2 connectivity, redundant networks, why redundancy is very important in case something happens to one network, other side will take care. Okay. And we're gonna also discuss link aggregation, how you can build redundancy through link aggregation. Okay. And then we're going to discuss routing protocols like OSPF, EIGRP, BGP. Those are very popular routing protocol in industry. We're going to discuss those protocols. We're going to talk about a little bit of network security and wireless networking concept. So this one is our agenda. Okay, so let's start. We're going to start first with the network design and troubleshooting. Let's see, somebody hire you as a network designer and you really want to design network for one company. So in this network design, you will see different types of networks like enterprise campus and enterprise edge, service provider edge, remote location. What is enterprise campus? Enterprise campus means where people are sitting. Okay, let's see if I have a big building. In this building, we have, 10th floor, total 10th floor. Every floor have around 50 users. So this one is your enterprise campus network. Sometime you are not having just one building, you have buildings and buildings like in a Cisco, in a North Carolina or San Jose. Cisco have a big campus, multiple buildings inside. I remember those days when Cisco have 12 or 15 buildings. Nowadays, maybe a little bit less. Cisco sold those buildings to somebody else. Okay, so buildings and buildings, and then what we can build, we built our access layer, distribution layer, and core layer. We're going to talk about what is access layer. I can give you a quick idea right now. Access layer means where end user devices are connected. Distribution layer means we're gonna aggregate those devices, and then we have core layer. over there we really want to send this information from one distribution layer to another distribution layer in a very quick manner. So our main focus is the speed. So how to build access layer, distribution layer, and core layer, we're gonna also discuss. But what is main campus is, main campus sometime one building, two buildings, three building, one geographic locations where you have your corporate network. Sometime your organization having a data center, it's in same building, it's in same campus. Sometime your data center may be in somewhere else, because nowadays we have lots of cloud networking. Sometimes you are having 50% machines on cloud, 50% machines basically on your own data centers. Sometimes you are having data centers in a same building. Sometimes you have having data center in other location. So this one is your campus network where all users are sitting, different floors, cubicles are there. Okay. And how I can connect my enterprise campus with other remote branches, with internet, with partners. So that's why we have enterprise edge. Okay. And enterprise edge basically connect your campus network with WAN providers. Okay. Sometime you are having WAN providers and we are having metro ethernet connections, like you have two offices in one city, or maybe you have multiple offices in different cities, and like in big cities metro ethernet is available. That's, you have one campus in New York and you have some branches in Texas or Chicago or somewhere else. So we have WAN providers. So WAN edge means, or we can say enterprise edge means, how I can connect my enterprise campus with other, remote branches or partners or other remote cities. Okay, so that is your enterprise edge. Here, if you guys notice, we are having firewalls, so we really want to protect our network. I don't want any hackers or crackers can enter in our network. So that's why we have a WAN edge. So WAN edge is very important part of your network. Okay. And what about internet edge? Internet edge means here in a WAN edge, if you guys notice, we are connecting with other branches. I have my branch office in Chicago. I have my branch office in Toronto. We based in New York, and we are having a WAN provider, and this is giving us metro ethernet. So there is no internet involved. You are connecting from service provider network to the other service provider network, and you are having a branch offices. Let's see, we have two branches in North America, one in Chicago, one in Toronto. For Chicago, there is a chance you can use WAN provider AT&T. Okay, and whatever in Toronto, AT&T handshake with Rogers or Thales, which is Canadian-based service provider. So from there you have connectivity. Okay. So WAN edge means your branches, your company branches, same company, but they have different geographical locations. So for that, we need WAN edge. Internet edge means I want to access my internet stuff. Okay, nowadays, not only you are browsing internet, but you are hosting your servers, because clouds is very popular. I remember those days, like 15 years before, cloud was not that popular, and people were thinking, do you think we're gonna put our servers on third-party cloud? And now I can see some companies are even having 100% servers in cloud environment. So that's why internet edge is very, very important. Let's see, your company have 50% server on-prem in your own data center, 50% servers on cloud. So internet access is very important, not only for just browsing internet or sending emails, plus you are hosting your server. So internet edge is also important. And how you gonna get internet connectivity with ISP, internet service provider. And nowadays, because many users are working from home, so we have a remote workers, they can simply connect with internet, and from there they can access to your campus network. So that is also possible through internet edge. So we have an enterprise edge. We can divide into internet edge and WAN edge. Okay. And after that, what we have locations like small branches. Sometime in remote locations, you have partners, partner branches. So these are my remote locations. So I can see I can divide my Cisco enterprise architecture into four big categories: enterprise campus, enterprise edge, service provider edge, and remote location. Okay. Okay, guys. Now, enterprise campus, like we discussed, we have our own environment, like one building, multiple buildings, even one floor. And over there, we are having our users, cubicles, devices, cabling. So that is your enterprise campus. Okay. So we can say in simple word, campus network span a fixed geographic area. It consists of buildings or a group of buildings connected into one network consisting of many network segments. Okay. And then we have Enterprise Edge. Enterprise Edge is this module provides connectivity outside the enterprise. Let's see, we are sitting in New York-based building and we want to talk to Chicago-based branch or Toronto-based branch or Europe, London-based branch. So that's why we need Enterprise Edge. And for that, we basically communicate with service providers. Different service providers are available and different types of connections available. So those connections we can simply manage through enterprise edge. Okay, and this module often function as an intermediary between the enterprise campus module to which it connects via its core and other modules. Service provider edge, a module that provides connectivity between the main enterprise side and remote location. So that is your service provider edge we just talked about. And then we have a different remote locations depending upon what kind of business you have. Sometimes you have a less location, sometimes you have a more location. Let's see, you guys are in restaurant business. Okay, you have main office, but you have let's see 300 restaurants, so you have more remote locations. Okay, so how you can connect your remote locations to your main campus network? So that's what we do through a remote location connectivity, or we can say a module that represent geographically distant parts of the enterprise network, such as branch offices, teleworkers. Sometimes people are working from home or remote data centers. Okay, so these are four main pillar of Cisco-based campus or enterprise network. Okay, enterprise campus, enterprise edge, service provider edge, and remote location. Okay. Sometime when we are having enterprise campus, if you have a flat network means all PCs and servers and printers are connected to each other, and we are sharing same layer 2 switches. Okay, so this flat network have no subnets, no VLAN. So this can make your life very difficult. If something happens to this big flat network, this can impact your whole network. So that's why what we do, we use hierarchical model. We divide our network into multiple VLANs and subnets, and that's why we use different types of layers. And that's what I'm going to show you after that slide. So, we can say in a simple word, we should divide our network into multiple layers. We should divide our network into multiple VLANs and subnets. So, there is a one rule, divide and conquer. So you can divide your network into smaller chunks so you can manage very easily from anywhere in the world. And if something happen in one side, it will not impact on other side. Okay, so that's why we always prefer hierarchical model. And after that, we're going to talk about hierarchical model also. Okay, so that's why you guys notice we are having three layers: access layers, distribution layers, and core layers. So on access layer, if you notice, we are using client access switches. Those switches are not very high-end switches. Whenever you go for Cisco site, and you will find some basics, lightweight switches. Those switches are directly connected with our endpoint devices. Endpoint devices means laptops, computers, printers, cameras, okay, wireless devices. So this is our access layer. So we can say access layer basically used to grant user access to network devices. It's like a window. Okay, if somebody want to connect to my network, so this guy will connect first to access layer. In a network campus, access layer generally incorporates switch LAN devices with port that provide connectivity to workstations and servers. Okay, and after that, let's see, this is my access layer. Let's see, this is my first floor. Okay, and this floor is first floor, this one is second floor, and in on first floor we have around 100 computers. So what we can do, instead of connecting those 100 computers to core layer, for floor number one or first floor, we have one switch. This is our distribution switch. So those switches are connected to this distribution switch. So the distribution layer simply aggregates the wiring closets using switches to segment work groups and isolate network problem in a campus environment. So if you have a distribution layer, if something happens here, this is not going to impact to other side. Okay, and you can manage things very easily. So distribution layer means we do our most of the policies, network policies, access layer policies, routing policies. So those policies we implement on distribution layer. And after that, we have a core layer. In this core layer, we have two switches. Why we have a two? Why we have a two switches in distribution layer? Because of redundancy. In case if one switch is down, other will take care. In case of one core switch is down, other will take care. Okay. So the main purpose of core layer is high speed backbone. We really want high speed connectivity on core layer. I don't want any policies on core layer. I don't want any delay on this core layer. We really want high speed networks on our core layer. That's why we have a dedicated switches available for core. Okay, and core layer basically it's your backbone layer. Okay, this simply designed to switch packet as fast as possible. Because the core is critical for connectivity, it must provide a high level of availability and adapt to change very quickly. So core layers, distribution layers, and access layer. Let's see, if I want to build any campus network, you guys will notice these three layers very popular in industry, and that's why we divide our network into three layers, and then we do further divide. We can create multiple VLANs. Let's see, I have a sales team. For that, I have a sales VLAN. I have a marketing team, engineering team, IT team. And so for all different teams, we built different VLANs, different subnets. And sometime if sales want to talk to IT, there is a possibility you guys can talk to IT team. Okay, that is possible because of inter-VLAN routing. But most of the time we divide our network into small chunks, small segments, so we can manage very easily. Not only departmental wise, we can divide our network because of layering, access layer, distribution layer, and core layer. Also, we create subnets. Okay, so that's the idea of hierarchical network design. So I don't have a big flat network. I have a hierarchical design. If any problem happens, I can fix quickly. If anything happens in my network through troubleshooting, I can fix very easily. If is there any security issues, I can fix very easily. That's why we have three layers. Okay. Okay, guys. Now, hierarchical network design model and switching mechanism. You know, we have hierarchical design, access layer, distribution layer, and core layer. But we are running different types of devices. We are having routers and switches. When when Cisco started, or like any other vendor started, so they started with process switching. What do you mean process switch? Is whenever packet enters in your switch, or if you have a routers, okay, so what happens in a process switching, router strip off the layer 2 header. Layer 2 header strips off means router will remove layer 2 information, which is MAC address information or layer 2 related information, and after that router really wanna look up the layer 3 destination network. Whenever packet arrive to router, I really wanted to know what is my layer 3 destination IP address, but first I have to remove layer 1, layer 2, and then only I can see. So this whole process actually happening in a software. So layer 3 destination network address in the routing table for each packet, and then send the frame with the re-return layer 2 headers, including computed cyclic redundancy, CRC to outgoing interface. So this is, very slow process. When we started first time, we started with process switching. Nowadays, nobody is using unless there is a big troubleshooting issue. You really wanted to see what's going on processor level. So if your network is not working, I want to troubleshoot, then only you can use process switching, but most of the time we are not using. Okay, so all these operations are done by software that is running on the CPU for each individual frame. So process switching is the most CPU intensive method. So whenever you use process switching, use it in a very careful manner. Sometimes why we do process switching, I cannot figure out my problems, troubleshooting is there, let's try process switching, and then we can figure out issues. Okay, like especially most of the time in troubleshooting time. But in a normal process, we not gonna use process switching because every packet is examined by CPU, and we cannot afford this much delay in modern networking world. Okay, so then we had, after that we have fast switching. Fast switching means after the lookup of first packet, we're gonna look for first packet. First packet goes to CPU because CPU will take time. CPU use software, and first packet goes to CPU, and that is destined for a particular IP network. So the router initialized the first switching cache that is used by fast switching method, only first switching, and then remaining traffic goes fast switching cache to destination side. Okay. So when subsequent frames arrive, the destination is found in the fast switching cache, and the frame is re-returned with the corresponding link address, and it's sent over the outgoing interface. So first packet only examined by CPU, but if you notice in previous case, every packet examined by CPU. So this method is faster than process switching. Okay. So, but after that, we have another method which is very popular nowadays, and our most of switches and routers are capable of this method, which is called Cisco Express Forwarding. In Cisco Express Forwarding, what your router or switch will do, routers, layer 3 switch, basically those devices build tables in a hardware, so then things will not go to CPU. So they're gonna build table in a hardware. One is called fib, okay, and other one is called adjacency table. One is layer 3 table, one is layer 2 table. Fib means forwarding information base, and adjacency table means it's a layer 2 table. Okay, so if you are looking for layer 3 information, you talk to fib. If you are looking for layer 2 information, you talk to adjacency table. So hardware forwarding tables are built by the CPU. All forwarding decisions are performed in a hardware tables, and hardware basically using electronic chips, flip-flops, and those circuits are really fast, and we do we move packet in a hardware speed, in a wire speed, which is very fast. So Cisco Express Forwarding is the default switching mode nowadays in devices. It is less CPU intensive than fast switching and process switching. A router with Cisco Express Forwarding enabled, by default it's enabled, uses information from table that are built by CPU, such as routing table and address resolution table. This is routing table means fib, address resolution table means adjacency table. And then we're gonna move our packets from one place to another place, source to destination. So nowadays, whenever you will see any Cisco latest greatest devices, latest greatest means 6 years old. After that, or even 7 years old. After that, all devices are working with Cisco Express forwarding. Okay, so which is very fast process. Okay, layer 2 connectivity, redundant networks, and link aggregation. You know, in networking world, redundancy is very important. Let's see, you guys notice this is switch A, this is switch C, and this one is switch B. We have multiple links. In case if this link is down, switch C cannot access to switch B if this link is down, but then switch C can access from other way. So that's why we are using multiple links. But there is a one big issues when you have a multiple links, this can create bridging loops. Okay, so that's why we are having some methods like spanning tree. Spanning tree started by one woman. She used to work for Cisco, very old lady. Rady Proman, she started this spanning tree, and the spanning tree solved lots of issues. But nowadays, in the latest greatest network, instead of using spanning tree, we are having some latest greatest method like fabric path, and we are using VXLAN. Okay, but still spanning tree is very popular. So spanning tree idea is if one link is down, other link will work automatically, and you're not gonna lose your connectivity. So we have a redundant links, and spanning tree basically it's one protocol. This can provide redundancy, and also I mean, you know, keep an eye on loops. If there is a loop, spanning tree stop that port. Okay. Sometime whenever you are connecting two devices and you have two links, link number one, link number two. This is link number one, this is link number two. So what happens when you have a two links, because of spanning tree, because of loop prevention method, this link is, I mean, you know, sort of disabled. It's not working. Physically it's connected, but it's not working. Why? Because there is a chance this can create loop. Okay, so that's why it's a loop prevention method, and this link is down. So what we are thinking, we have a two links, maybe one link speed is 1 gigabit, other link speed is 1 gigabit. So if we can use both links, so we're gonna get 2 gigabits. Right now at this moment we are having only 1 gigabit. Okay, so what we can do, we can build ether channel. So why not we combine these two ports, and why not we combine these two ports, and we basically built ether channel. Okay, so what we can do, we can build ether channel, and you guys notice here we built ether channel. Once you build ether channel, so and if you can see through spanning tree glasses, if I will put my spanning tree glasses, and if switch will see, oh, this is one logical link, and they're not gonna stop that port. So logical link aggregation, we do load sharing, plus same time we are using both links. Before there was no spanning tree, before there was no link aggregation, so that time we were using only one port, like we have only 1 gig speed, but now we are having 2 gig speed, and we built port channel. Okay, so we do load sharing, we do redundancy. In case if one physical port is down, other physical port will take care. One logical port for STP, high bandwidth. And let's see, hey, Mr. STP, if you really want to see this link, and STP say, yeah, I can see that link, but it's a one logical link. I cannot see two links, so I cannot stop one port. So if you put spanning tree glasses, you're not gonna see two links, you will see only one link. But behind the scene, you are running two physical links, and we simply bundled, we simply built one port channel, and in this way you have redundancy, load sharing, and plus your bandwidth is also double. Okay, or how many cables you can add, how many links you can have depending upon switch. Sometimes you can have 8 links. So let's see, every port is 1 gigabit, so you will get 8 gig port channel. Or sometime even what you can do, you can have 16 links. So you have a 16 gig port channel, or let's see if your one port channel is 10 gig. So 10 multiplied by 16, 160 gig link port channel, you're gonna get it. And sometimes people confuse, sometimes somebody say ether channel, sometimes people say port channel, same idea, just two different terminologies. Okay, so if you build port channel, Hispanic tree not gonna block your port. Okay, so that's the big advantage of link aggregation. Okay, so now what we're gonna do, we're gonna discuss routing protocols. Sometimes people really wanted to know what is routing protocols, and we're gonna also discuss network security and wireless networking concept. Routing protocols means, let's see, I can give you a very simple example. You are sitting in a taxi and you really want to go from one place to another. Let's say you are traveling from your place to airport. So, but you have to tell taxi driver, hey, this is my address, that is my destination, I want to go over there. So if you're not going to tell a taxi driver address, even cab is there, a taxi driver knows driving, and but if you don't know your destination, this guy cannot take you to anywhere. So the same way we have a TCP/IP protocol. TCP/IP protocol act like a routed protocol. Routed means TCP/IP will take you from one place to another. Means take you your information, your packets, your data from one side to another side, or one computer to another computer. TCP/IP is capable, but TCP/IP always asks question. Okay, please tell me what is your destination. If you're not going to tell destination to TCP/IP, TCP/IP won't be able to take your packets, your frames, or your information from one place to another place. Okay, so like I gave you example of taxi driver, this guy knows driving, having a cab, but if you don't know your destination, you won't be able to travel, or you won't be able to reach to your destination if you don't know what is your destination address. Okay, so why we are using routing protocol? Routing protocol simply provide addressing. Okay, let's see, we based in Chicago and we really want to connect to Toronto and other office in New York. So we should know our Toronto based router address. We should know our New York based router address. Then only we can move our packets from one place to another. So the same idea we have with routing protocols. So routing protocols provide addressing information, and TCP/IP will move a packet from one place to another. So that's why we are using routing protocols. Okay. We have a different types of routing protocols: EIGRP, enhanced interior gateway routing protocols, and this protocol is actually from Cisco. Okay, proprietary protocols, and this one is advanced distance vector protocols and Bellman Ford based style routing protocols. And in this routing protocols, we basically use distance vector and also shortest path first protocol combination. So I would say it's like a hybrid type of protocol. We used to call hybrid protocol, but then Cisco say don't say hybrid, call it advanced distance vector protocol. Okay, so there are two types of protocol: distance vector protocol, like RIP is pure distance vector protocol, OSPF is pure shortest path first protocol, STP protocol, or EIGRP. Basically it's a combination of a distance vector and shortest path first protocols, or we can say a link state protocol. So we have two types of protocol: link state protocols, distance vector protocol. What is link state protocol? What is distance vector protocol? So these two protocol have a different style of communication. Let's see you are driving a car, okay, and you really want to go from one place to another. Let's see you are driving a car in a New York and you really want to go from New York to New Jersey, okay. There are different two tunnels, Lincoln tunnels, Holland tunnel. So but you are not having any GPS in your car. So what you gonna do? How you gonna reach? You're gonna read signboards, okay. So that's the way distance vector protocol works. Distance vector is light byte protocols, and distance vectors say I have not big database, but I will learn information from other neighbors. One router will talk to router 2, router 3, router 4. By learning information from other neighbors, you basically move your packet. So that's the way distance vector works. While you are driving a car, you are reading a signboards because you don't have any GPS in your car, okay. Link state protocol means in link state protocol like OSPF, ISIS, those are link state protocols. So those protocols are having actually big database. So that's why you are using, not like teeny mini type of devices, high end advanced devices when you are dealing with OSPF or ISIS. So because every router have a big database, so it means you have a GPS in your car, and while you are driving, you put your source address, your destination address, and then you can reach to your destination address because GPS basically connected with big database, so you can access to your place. You follow GPS. So that's the way link state works. So routing protocols simply guide your address, okay. So two types of routing protocols, link state and distance vector. EIGRP, basically it's a combination of link state and distance vector, and this is Cisco proprietary protocol. And after that, we have OSPF, which is very most popular protocol in this world because OSPF is a standard protocol. In OSPF, we use cost as a metric. And in OSPF, we basically, use very high CPU utilization because in OSPF routers are dealing with big databases, okay. And it's ideal protocol for large networks. Let's say you have a big organization. You guys are working in North America, Europe, Africa, Asia, China. So you really want to build your protocols. You can go for OSPF. Most of organizations are using OSPF. Let's say you are a company based in North America. You are all Cisco shop. You can go for EIGRP. So depending upon type of network, because why I always recommend OSPF, because sometimes you are dealing with different service providers. Some are in Europe, some are in Asia, some are in different places. Then they are using not only just Cisco devices, some other devices, and those devices, everybody understand OSPF. And that's why OSPF is most popular protocol, okay. Okay, guys, in OSPF, we do route summarizations and we can, summarize our routing table to get better performance. We're gonna also discuss BGP in a detail in this training, like when you guys gonna join ENCOR. BGP is Internet Protocol. That's the Internet having huge addressings or like say big databases, huge routing tables. BGP is a one protocol. That protocol can handle internet. So your whole internet is depending upon BGP. So BGP used as the routing protocol to exchange routes between autonomous system. Autonomous system means one company, owned by one person, or so different autonomous systems we have in worldwide, owned by a group of people. So autonomous system means one organization. So BGP connect different organizations to each other through internet. So your entire internet is depending upon BGP. And in BGP, we basically use MPLS implementation also, which is our underlying routing foundation of internet, okay. And it's very complex protocol, very advanced protocol, very slow protocol, and a very popular protocol on internet side, okay. So in our and in this ENCOR training, we're gonna talk about those three routing protocols, which is very popular. RIP nowadays nobody's using, so that's why we're not gonna discuss in this training, okay. So let's start a little bit idea of EIGRP. EIGRP is basically sort of a proprietary protocol. managed by Cisco. Okay, in EIGRP we can do load balancing. Let's see if I have a multiple links from Chicago to New York and then Chicago to Toronto. So we have two links available. So we do load balancing through EIGRP. Multi-address family actually work IPv4, IPv6. There is a loop-free, topology. There is no loop because EIGRP have a loop-free mechanism. Those mechanism checks if is there any loop. So it's a loop-free topology protocol. And this can also work with classless routing protocols. Classless means in this environment, we are using subnetting. We are not using just class A, class B, and class C addressing. We basically use different classless addresses, like we create different subnets. So this can work with class A, class B, and class C. Plus, this protocol can handle all subnets and VLANs very easily. Reduce bandwidth usage, because in this protocols we really want to send only if there is a change. We're not going to send unnecessary traffic from one router to another router. So that's why EIGRP is very popular. And if you are running all Cisco devices, and if you and you are not having very large network, you are not working in different part of world. Let's say you have a company based in North America. So most of typical North American based companies are using EIGRP. EIGRP is very popular protocol also. Okay. After EIGRP, we have OSPF. So right now, I'm just giving you basic idea, but when you guys will join that ENCOR training, we have complete day one discussion, okay? We're gonna talk about EIGRP, OSPF in a very detailed examples, hands-on lab, okay? Uh, and so that's what we do in our training, okay? OSPF is link state routing protocol. You can think of link as an interface on a router. So in an OSPF world, everybody knows everybody, and we built a big database. And that's why in OSPF world, we basically need high-end devices. Those devices can handle big databases. OSPF actually work on LSA. LSA is link state advertisement. Let's see if this router want to talk to that router, and then that router want to talk to that router. Let's see, we have three branches. So we basically send LSA to other branches, link state advertisement, and based on this link state advertisement, those router built neighbor relationships and then exchange routes and then transfer our informations, data from one side to another side. Okay. And now, after that, we are having a BGP. You know, what is the main difference between BGP and OSPF and EIGRP? OSPF and EIGRP, we just talk about those protocols are IGPs, interior gateway protocols, means those protocols works in a one autonomous system. Let's say I have my company, we have multiple branching owned by one organization. So those protocols are designed for that purpose. Let's say I have a company, DHL owned by DHL, okay, some people's, okay, directors. So that company is your organization. So inside of DHL, I can use OSPF, I can use EIGRP because this is autonomous system protocol, interior gateway protocols. But let's see if you are having internet. So on internet, we are dealing from one organization to another organization. So if you guys notice over here, this is autonomous system, and in this autonomous system we have IGP. IGP means interior gateway protocol. So these two guys, OSPF and EIGRP, those two protocols we can use within your organization, within autonomous system. And here also we have a same example. In one IGPs, we can use OSPF. Let's see, in this IGP, we have multiple geographical locations, Europe, Canada, US, Asia. And so for that, we basically use OSPF or EIGRP. But let's see if this autonomous system 6500, that is autonomous system 6500, one organization want to talk to another organizations through internet. So we call it BGP, Border Gateway Protocol, or we can say in simple way EGPs, Exterior Gateway Protocol. So IGP means Interior Gateway Protocol within one organization. EGP means there is a communication between different organizations, one organizations to another organization. That's why we have Exterior Gateway Protocol, which is BGP. And BGP is very popular protocol, especially on internet. Your whole internet is depending upon BGP. Okay. So now here we're gonna discuss some network security. Folks, network security is very important. Let's see if your campus network is compromised, okay? And if somebody knows, oh, your campus network is compromised, your organization lose its credibility. Let's see, you are matchmaking company. You guys are having matchmaking business, okay? And if somebody actually capture your information and this guy can sell that information, so maybe many people will lose their personal life. Or let's see, your company is financial organizations having lots of credit cards information. If somebody attack and capture that credit card information, that company lose credibility, lose business. So that's why network security is very, very important. Okay. Basically, ENCOR is not network security course. We have a separate track for network security, CCNP network security, but we're gonna discuss basic a little bit of network security, how you're gonna protect your network from crackers or hackers, or there are bad guys, they really want access to your network. So, you know, in a hacking world, you have a black hat people, white hat people. Black hat people always do attack because of bad purpose. White hat people will do attack and they really want to learn, I mean, you know, those vulnerabilities, why we have this issue. So that's why we're going to secure our network. So white hat people means those security auditors. Hey, why you are hacking? Because I really wanted to check whether your network is secure or not secure with your permission. So if your network is not secure, I'm going to tell you, hey, Bob, your network is not secure. Many ports are open. Any cracker or hackers can access to your network. OK, so this type of informations we basically share with organization. So those are white hat hackers hired by organizations, and they are paying money to them because they do attacks or cracks with the help of their permission. OK, and they really want to figure out, is there any vulnerability, your network is not secure or secure, and then they're going to make documents and charge money. Okay. Black hat means they really want to attack your network and they have evil or bad, I mean, you know, or malicious kind of mindset. So they really want to destroy your network. They really want to get your information, want to sell your information on those sites. Okay. So those are black hat. You know, so those type of folks are there. So you should, I mean, you know, secure your network. How we can secure our network? We are using firewalls, so this can protect our network from outsider. Not only just this, sometimes you have attackers or crackers inside of your network. So that's why you need to configure your routers, your switches, your network devices in a secure way. So even your insider people who are working in your company, they are not happy with organizations. They really want to do attack. So if you really want to stop those guys, so that's why you really secure your enterprise network. You need switch securities, you need router security. That's what we're going to talk about for enterprise point of view. Little bit discussion of firewalls, but if you are looking more detailed information, there is a separate security track. Okay. So that's why network security is very important, and how we can get network security in routing world. So whenever router talk to another router, let's see your router based in Chicago, one router based in New York, if they really want to talk to each other, so we should need authentication. Hey, you are the right router. I am the right router. Let's talk to each other. How you can say you are the right guy? Please share your key and I will check with my database. You can share with me, or they simply exchange certificates to make sure you are communicating with the right device, and then you can exchange your information in a secure way. So all these options available in a Cisco devices or in Cisco switches, and when we are communicating with internet, or we are browsing our servers and those server based on a cloud, so then we put so much security in our firewalls. Okay, so what kind of bad security policies we have, we're gonna also talk about in 40 hours ENCOR class, so which is also very important. Wireless networking concept we're gonna also discuss here, because nowadays, if you guys notice, like 10 years or 15 years old network, that time I noticed most of devices are wired devices. And then nowadays, most of devices are wireless devices. People are bringing their laptops, people bringing iPad, people are bringing cameras or some other type of devices, and those devices are using wireless connectivity. Okay, how to deal with wireless network, how to establish wireless networks. Sometimes you have a small environment, you can just buy one access point, connect access point with your router, and your wireless network is ready. But sometimes you are having a big environment like a big shopping mall, and you are not having one access points, you are maybe you are running 1000 access point, airport, university campus. So how to build your wireless network, we're gonna discuss in this ENCOR, and how I can control my wireless access point, because I gave you example, we are having 1000 access points. How I can control my 1000 access point in a wireless world, and that's why you need wireless LAN controllers. And from one controller, we can manage our APs. APs means access points, and then we can run our smooth wireless network. So what Cisco did, Cisco basically combined in enterprise CCNP, or in this training, Cisco combined wireless, route and switch together. Before, like, before this CCNP, like 5, 6 years before, wireless was separate track, route and switch was separate track. But what Cisco did in Cisco Enterprise, Cisco combined wireless and route and switch steady. And now we are discussing wireless in this network. Let's see, if you are looking for more wireless details, maybe after ENCOR, you can choose any optional wireless courses in a more detailed 5-day detailed wireless discussion. Okay, so we're gonna cover wireless also in this training. Okay. So thank you very much. If you guys have any question, please feel free to ask. I really appreciate your question. Bring your question in this class. Okay. Ask as many as questions possible.
Thank you, Talib. That was very informative. I know everyone is looking forward to the Q&A session, so go ahead and start putting your questions into the questions panel. And now I'd like to give the presentation rights over to Robin, our vendor manager, to introduce our promotions and webinar-related courses.
Thank you for extending to me this opportunity to speak with our attendees today. First of all, thank you everyone for attending this webinar on the best practices and implementation strategies with Cisco ENCOR version 1.2. I sincerely hope that it added value to your knowledge of Cisco. In case you feel like revisiting this session for any reference, please feel free to do so by clicking on the access recording button, and we would be more than happy to make it readily available to you. Next, I would like to offer you a glimpse of Netcom Learning's capabilities and why we are the best that there is when it comes to learning services, training, talent development, and beyond. I take pride to announce that we have been recently announced as the winner of 2023 Microsoft Learning Partner of the Year. Netcom Learning has been into managed learning space for 2.5 decades now and have provided its services to 80% of the Fortune 1000 companies. Having a strong reputation in B2G sector, Netcom has served over 100 US military bases. We have trained over 175,000 professionals to learn and grow in their respective fields across 16,000 enterprise clients. We cherish a recommendation rate of 96% from our customers. All these numbers I just mentioned have been a result of our specially curated trainings delivered by a portfolio of 3,000 plus certified trainers. Moving ahead, being an authorized Cisco learning partner, I would like to give you a glimpse of Netcom Learning's upcoming schedules of courses from Cisco that are highly recommended for you to expand your horizon and knowledge of Cisco. To add value to your learning curve, we encourage you to access our free on-demand trainings and blog posts related to Cisco. Today, I would like to use this opportunity to announce that Cisco U is available for everyone. Cisco U is a digital learning experience dedicated to helping teams and learners to streamline their learning journey through guidance and personalization. With an AI ML engine, Cisco U recommends content and provides personalized feedback through assessment that validates skill and guide learners through their personalized content. For an effective learning curve, you can choose from Cisco U Essentials or Cisco U All Access. Cisco U prepares you for industry-leading associate level certifications, whereas Cisco U All Access would unlock all Cisco U content to meet any career goal of yours within the Cisco ecosystem. Inside these packages, you and your team will find in-depth learning path, access to hands-on labs, providing a learning journey that focuses on target skills as well as the moment of need solutions that are needed for your organization's transformation and solution. I would also like to emphasize on the limited time discount that we are running that is valid until 29th of July 2023, wherein you can have Cisco U Essentials in $1,500 or 15 CLCs, whereas Cisco U All Access is available in $4,800 or 48 CLCs. Next, you can also take advantage from Learning Passport, which is Netcom solutions to a flexible team training. It is designed to be customized in line with the number of learners that you plan to train from top technology vendors like Microsoft, Cisco, Adobe, and more. The single package can be redeemed over 4,000 plus official courses with a validity of 12 months. Keeping in mind the requirement of our customers, you can further choose from Learning Savings Passport or Learning Vouchers Passport as per your need and requirement. I would like to introduce you to Netcom Plus Learner Subscription, which is a learning solution that we have developed for our enterprise customers. All you are required to do is invest one time and reap the benefits of the unlimited access to authorized training from top technology vendors like Microsoft, AWS, Cisco, and more through a span of 12 months. As displayed on your screen, we deliver these subscriptions in three types of packages. The free or the silver packages allows you to access 300 plus e-learning modules, or you can go for gold at $199. That will give you an access to 400 plus e-learning modules along with the silver package benefits. Third, we have for you the best selling and the most popular platinum package at $299. That gives you an access to 400 plus e-learning modules plus 120 plus virtual instructor-led training in addition to the gold package. Also, I would like to recommend you to go through Netcom's website for more information, such as the courses and certifications that we have for you, our free virtual events, blogs, and our promotions. If you're looking to have a leadership point of view on the importance of lifelong learning and building smart workforce, I highly recommend that you go through the book Building an Innovative Learning Organization by Russell Sadler, CEO of Netcom. You can easily find it on Amazon. With that, I sincerely hope we could add value to your knowledge base in the time you choose to spend with us during this webinar. For more information on sessions and latest updates on IT and business training, please follow and give us a shout out on our LinkedIn, Instagram, YouTube channels. Thank you once again for joining us.
Thanks so much for guiding us through all that information, Robin. And now we're going to go ahead and jump right into our question and answer session. If you haven't yet, it's not too late to pop your questions into the question panel. And as we start our Q&A sessions, we're also going to launch a quick poll that we want to invite you to participate in. Doing so helps us to know how we can better serve you by telling us who might be interested in more information or in taking some additional training. In addition, we have a lot more informative webinars coming up, so please go to netcomlearning.com/webinars in order to register. First question for today is, how does ENCOR v1.2 integrate with other Cisco networking technologies and solutions?
Okay, very good question. You know, if you want to start your career in a Cisco world, so we start first with CCNA, route and switch, and after that, once you complete your route and switch, you should start with CCNP Enterprise. CCNP Enterprise will give you your infrastructure information plus a little bit of security, a little bit of wireless, plus data centers and service provider information. So this can give you very good foundational building blocks. Based on that knowledge, you can even pick, oh, I really like security, I want to be security professional, or maybe you can choose data centers or service provider track. So your all tracks are, I can say in simple other word, depending upon this enterprise and core certification.
Let's take another question. Can you provide a brief overview of the ENCOR v1.2 migration process?
Yes, because you know what happens if you are having older CCNP and your older CCNP is simply expired, okay, and so if you really wanna you really wanna do recertification, so ENCOR is latest greatest version. So you can attend this course and you can recertify your certification. So in this way, you can upgrade to your certification. The way technology is changing, before we had manual configuration, we do device by device configuration. Now, most of configurations are depending upon controllers like software defined networking. So whenever you choose ENCOR, so not only you recertify, plus you can update your information, which is software defined networking. And now you guys will see after 5 years, very few people are gonna use manual configurations. Okay, so in this way you can upgrade.
Next question up in the queue is, what resources are available for learning ENCOR v1.2?
Different types of resources. You can join instructor-led course. You can simply enroll with a netcom and join instructor-led course. There is a self-paced course also available, like you can join self-paced, or even you can buy books, a self-paced book from Cisco side, and then you can rent out labs even from Cisco side, and you can prepare. And once you complete your training, after that, you should go through question answers. So I mean, you know, question answers, flashcards are definitely help. And I would say after attending instructor-led training or even self-paced training, you need some time, at least 1 month to prepare for exam. And then once you pass your exam, then you will be ENCOR certified. So idea is simple: instructor-led, self-paced, question answers, and you know, flashcards. So those are resources available, okay, directly. Even it's available from Cisco side, or even you can get those resources from Cisco education partner. Okay.
Once again, I want to remind you that as you leave the session today, you will be presented with a short survey. We would like to request for you to help us by taking a quick moment to participate in that survey. Your feedback really helps us understand your learning experience as we are constantly looking at how we can improve our future sessions. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. We want to thank all of you for joining us today, and if you do come up with any additional questions, feel free to send them to webinar@netcomlearning.com at any time. We hope that you found today's webinar informative, and we look forward to seeing you back here with us soon. Feel free to tell your friends and colleagues about our webinars and other courses. Have a great day, everyone.